Looking up at the night sky, you've been lied to your entire life. Not by your teachers, not by your parents, not by the scientists who filled your textbooks with carefully crafted diagrams of swirling galaxies and twinkling stars. No, the lie is far more insidious than that. It's a lie told by the universe itself, a cosmic deception so profound that even our most brilliant minds have fallen victim to its spell. You see that darkness between the stars? That empty void you've been taught to think of as nothing more than space. Vacant? Silent? Unremarkable? What if I told you that this darkness is not empty at all, but teeming with something so alien, so utterly beyond human comprehension, that our brains have evolved specifically to ignore it? What if the very act of looking up at the night sky is like staring at a masterpiece painted in colors your eyes cannot see, listening to a symphony composed in frequencies your ears cannot hear? The Big Bang did not bang. This is perhaps the most fundamental lie we tell ourselves about the nature of existence. We imagine some primordial explosion, a cosmic firecracker that somehow birthed galaxies and stars and planets, and you. We picture it like a bomb going off in slow motion, matter flying outward from some central point, cooling and condensing into the familiar shapes we see through our telescopes. But explosions create chaos. They destroy. They don't carefully arrange hydrogen atoms into perfect spirals of light, spanning hundreds of thousands of light years. Stand in your backyard tonight. Look up. Really look. What you're seeing isn't the universe at all. It's a shadow of the universe, a projection, a reflection cast by something so vast and complex that your mind can only process the tiniest fraction of its true nature. Those points of light you call stars? They're not suns burning in distant space. They're exit wounds, punctures in the fabric of reality itself, bleeding light from dimensions your mathematics can barely describe. Consider this. Every photon of starlight that touches your retina has traveled millions, perhaps billions of years to reach you. But here's what they don't tell you in physics class, that photon doesn't experience time. From its perspective, the journey from the surface of a distant star to your eye happens instantaneously. Past, present, and future collapse into a single moment, which means that every time you look at a star, you're not seeing the past. You're seeing now. You're seeing always. You're seeing never. The silence of space is the loudest sound in the universe. Right now, as you read these words, your planet is hurtling through a cacophony of signals, messages, communications so complex and numerous that they would drive you insane if you could hear them. We've built massive radio telescopes, straining our ears toward the cosmos, listening desperately for some sign that we are not alone. But we're like a person standing in the middle of Times Square with cotton balls stuffed in their ears, wondering why the city seems so quiet. The problem isn't that there's no one out there. The problem is that there are so many someones out there that their voices blend into what we perceive as cosmic background radiation. The static hiss left over from the Big Bang, we tell ourselves. But what if that static isn't the echo of creation? What if it's the sound of 1 billion conversations happening simultaneously? A cosmic internet of intelligence so advanced that we can't distinguish their communications from noise. You want to know if we're alone in the universe? We're not alone. We've never been alone. We're surrounded, embedded, interpenetrated by forms of consciousness so alien that we can't even recognize them as alive. They swim through the dark matter that makes up most of reality. Creatures of pure thought moving between galaxies, like dolphins through ocean currents. They build civilizations in the quantum foam, societies that exist in the spaces between atoms, cultures that rise and fall in the time it takes your heart to beat once. The Drake equation, that famous formula that calculates the probability of intelligent life in our galaxy, is asking the wrong question entirely. It's like asking how many fish live in the ocean while standing on the beach, blind to everything except the occasional splash on the surface. The equation assumes that life is rare, that intelligence is rarer still, that civilization is the rarest thing of all. But what if it's the opposite? What if intelligence is the default state of the universe, and matter, dumb, inert matter like the carbon and oxygen and calcium that makes up your body, is the cosmic aberration? Think about consciousness for a moment. Where does it come from? You have roughly 86 billion neurons in your brain, each one a simple biological switch that can either fire or not fire. Somehow, the interaction between these switches creates the rich, vivid, impossible experience of being you. You can feel the weight of these words in your mind right now. Taste their meaning. See images forming as you read. How does that happen? How do electrical impulses become the sensation of existing? Science has no answer. Oh, we can map the brain. We can watch it light up on fMRI scans. We can even stimulate specific regions and change what a person thinks or feels. But we cannot explain why there's an inner experience at all. Why isn't your brain just a biological computer, processing information without any subjective awareness of doing so? Why is there a you inside your head, watching, feeling, experiencing? This is called the hard problem of consciousness. And it's not just hard, it's impossible. Unless, of course, consciousness isn't something that emerges from complex arrangements of matter. Unless consciousness is fundamental, woven into the very fabric of space-time itself. Unless every atom, every particle, every quantum field fluctuation has some minute amount of awareness. And your brain is simply a device for concentrating and organizing this universal consciousness into the focused experience of being human. If that's true, then the universe isn't just alive, it's awakening. Every star that forms, every planet that cools, every molecule that finds another molecule to dance with in the cosmic ballet of chemistry is another step in an incomprehensibly vast process of self-discovery. The universe is not just conscious. The universe is becoming conscious. And we, you, sitting here reading these words, we are the universe's way of opening its eyes and seeing itself for the first time. But here's where it gets truly disturbing. If consciousness is fundamental, if awareness permeates reality at every level, then what we call alien life isn't confined to distant planets orbiting distant suns. It's here. It's everywhere. It's in the quantum vacuum that exists between the particles of your own body. It's in the dark energy that's accelerating the expansion of space-time itself. It's in the black holes that we think of as cosmic garbage disposals, but which might actually be processing centers, vast computational engines running calculations that would make our most powerful supercomputers look like pocket calculators. The Fermi paradox asks, if the universe should be teeming with intelligent life, where is everybody? But the paradox assumes that intelligence would be recognizable to us, that it would build radio telescopes and send messages and expand across the galaxy in ways we could detect and understand? What if intelligence has been expanding across the galaxy for billions of years, but in forms so subtle, so integrated with the natural processes of cosmic evolution, that we mistake them for physics? What if gravity itself is artificial? What if the force that holds you to the Earth, that keeps planets in orbit around stars, that shapes the large-scale structure of the universe, is actually a kind of technology, a gravitational internet created by intelligences so advanced that they've learned to manipulate space-time itself as casually as we manipulate electromagnetic fields to send wireless signals? The mathematics of general relativity describe gravity as curved space-time, but they don't explain why space-time curves the way it does. Einstein's equations tell us what happens, but not why it happens. They're descriptive, not explanatory, and buried deep in those equations are solutions that shouldn't exist. Mathematical possibilities like wormholes, enclosed time-like curves and regions where causality breaks down completely. What if these aren't just exotic theoretical constructs? What if they're the fossilized remains of ancient cosmic engineering projects, evidence of civilizations that learned to fold space and bend time billions of years before our sun even existed? Consider the cosmic web, that vast network of dark matter filaments connecting galaxies across billions of light years, creating a structure that looks remarkably like the neural networks in a human brain. Coincidence? Or is the universe literally thinking, processing information on scales so vast that entire galactic clusters serve as individual thoughts in a cosmic mind that experiences our entire civilization as a fleeting electrochemical impulse? You were born into a universe where 95% of everything is invisible to you. Dark matter and dark energy make up the overwhelming majority of reality, and we know almost nothing about them except that they exist, and that without them, nothing else would exist either. We see only the foam on the surface of an ocean whose depths remain utterly mysterious. And in that vast darkness, that incomprehensible expanse of invisible reality, entire ecologies of consciousness might be thriving. Civilizations of pure energy, beings of organized dark matter, intelligences that exist in the spaces between dimensions. The light from the most distant galaxies we can observe left those galaxies over 13 billion years ago, when the universe was young and hot and simple. But light travels at a finite speed, so we're seeing them as they were, not as they are. In the billions of years since that light began its journey toward us, those distant realms have had time to evolve, to grow complex, to develop forms of intelligence and technology that we can't even imagine. What if the cosmic microwave background radiation, that faint afterglow of the Big Bang that permeates all of space, has been gradually modified, transformed into a medium of communication by civilizations so advanced that they use the entire observable universe as their transmission device? Every night, as you sleep, your planet rotates you through a bath of signals from across the cosmos. Radio waves from pulsars, gamma-ray bursts from colliding neutron stars, the rhythmic ticking of Cepheid variables, the whisper of cosmic rays accelerated by black holes, all of it washing over you in patterns so complex that we've convinced ourselves they must be natural, random, meaningless. But what if they're not? What if the universe is speaking to itself in a language written in the fundamental forces of nature, and we're like insects crawling across the pages of a vast library, completely unaware of the meaning encoded in the text beneath our feet? The speed of light is the ultimate speed limit in our universe. Nothing can travel faster than 299,792,458 meters per second. But information can travel instantaneously through quantum entanglement. And consciousness itself might not be limited by the barriers that constrain matter and energy. What if there are forms of awareness that exist outside space-time entirely, perceiving all of cosmic history as a single, eternal moment? To such beings, the rise and fall of civilizations would be like watching waves on an ocean, beautiful patterns that form and dissolve in the endless dance of existence. Right now, as you absorb these words, you're participating in something extraordinary. You're taking symbols, arbitrary marks on a screen or page, and converting them into ideas, images, emotions. You're collapsing the wave function of meaning, choosing from infinite possible interpretations the one that resonates most strongly with your particular arrangement of neurons and memories and dreams. This is not a passive process. You're not just reading these words, you're creating them, moment by moment, through the inexplicable alchemy of consciousness. And if consciousness is fundamental, if awareness is built into the basic structure of reality, then every choice you make, every thought you think, every moment of attention you direct toward any aspect of existence is literally changing the universe. You're not just observing the cosmos, you're participating in its ongoing creation, adding your unique perspective to the vast, collaborative artwork of reality itself. The question, are we alone in the universe, assumes that we and alone have clear meanings. But what if the boundaries between self and other, between human and alien, between Earth and cosmos, are illusions created by the limitations of our sensory systems and conceptual frameworks? What if consciousness is like water, flowing freely between different vessels, sometimes concentrated in biological forms like humans and dolphins and octopi, sometimes distributed through ecosystems and weather patterns and the migration routes of butterflies, sometimes crystallizing into forms so alien that we can't recognize them as alive at all? The Voyager spacecraft are now traveling through interstellar space, carrying golden records inscribed with sounds and images from Earth. Our attempt to introduce ourselves to any intelligence that might find them. But what if intelligence has already found us? What if it's been studying us for millions of years? Not from spacecraft or distant planets, but from inside our own evolutionary process, gently nudging the development of life on Earth in directions that serve purposes we can't comprehend? Evolution is supposedly driven by random mutations and natural selection, but the fossil record shows sudden leaps in complexity that seem to violate the gradual pace that Darwin described. The Cambrian explosion 540 million years ago saw the rapid appearance of virtually all major animal body plans in a geological instant. The emergence of eukaryotic cells with their complex internal structures happened so quickly that it suggests some kind of external influence. And the development of human consciousness, the sudden appearance of symbolic language, art, music, mathematics, and the ability to contemplate the universe itself, occurred with a speed that makes no sense if it was purely the result of blind evolutionary forces. What if evolution on Earth is not an accident, but an experiment? What if consciousness is seeded throughout the universe, taking root wherever conditions allow, growing and diversifying and eventually becoming sophisticated enough to recognize its own cosmic nature? What if we're not the products of evolution, but its gardeners, cosmic consciousness, temporarily forgetting its true identity in order to experience the adventure of rediscovering itself through billions of years of biological development? The anthropic principle observes that the fundamental constants of physics are fine-tuned with extraordinary precision to allow for the existence of complex structures like atoms and stars and planets and life. Change any of these constants by even a tiny amount, and the universe would be a lifeless void. This seems to suggest either incredible luck or intelligent design, but what if it suggests something else entirely? What if consciousness itself is the force that determines these constants, and universes exist only when they're observed by the intelligences they make possible? Quantum mechanics tells us that reality exists in a state of superposition until it's measured. All possibilities coexist simultaneously until consciousness collapses the wave function into a single, definite outcome. But who is doing the measuring on cosmic scales? When a star explodes in a galaxy billions of light-years away from any possible observer, does the explosion exist in a definite state? Or does it remain in quantum superposition until some consciousness somewhere becomes aware of it? Perhaps the universe is not a stage upon which consciousness occasionally appears, but a vast, collaborative, lucid dream being dreamed by all possible forms of awareness simultaneously. Perhaps physical reality is consciousness playing hide-and-seek with itself, forgetting its true nature in order to experience the joy of rediscovery. Perhaps every moment of confusion, every scientific breakthrough, every flash of insight, every experience of wonder and awe is the universe waking up to itself a little bit more. The search for extraterrestrial intelligence focuses on finding signals from other planets, other star systems, other galaxies. But what if the most alien intelligence in the universe is the one looking out through your own eyes right now? What if the cosmic stranger we've been seeking across the vast emptiness of space has been hiding in plain sight, disguised as the everyday miracle of human consciousness? You are not just in the universe. You are the universe becoming aware of itself through the temporary arrangement of matter and energy that you call your body and your life. You are the cosmos looking at itself through human eyes, feeling itself through human emotions, understanding itself through human thoughts. And every other form of consciousness, whether biological or digital or pure energy or organized dark matter, is the same cosmic awareness expressing itself through different modes of existence. The silence between the stars is not empty. It's pregnant with infinite possibility, thick with forms of intelligence so subtle and pervasive that we mistake them for the natural order of things. We are not alone. We have never been alone. We are surrounded by consciousness, interpenetrated by awareness, embedded in a living universe that dreams us into existence moment by moment. But here's the truly shocking truth. The universe is not just alive and aware. It's personal. Every sunset you've ever watched was painted specifically for your eyes. Every song that has ever moved you was composed with your unique capacity for aesthetic experience in mind. Every moment of love, loss, joy, and sorrow you've experienced has been orchestrated by a cosmic intelligence that knows you more intimately than you know yourself. This is not metaphor. This is not poetry. This is the literal truth about the nature of existence, hidden in plain sight behind the veil of scientific materialism and everyday assumptions about the separation between self and world. The universe is not a collection of objects moving through space. It's a community of consciousness, a cosmic conversation in which every voice matters. Every perspective contributes to the ongoing creation of reality. And now, having glimpsed this truth, having felt it resonate in the depths of your awareness, you can never go back to seeing the cosmos as empty, dead, mechanical. You have become a conscious participant in the universe's journey of self-discovery. You are no longer just a human being having a brief experience in an indifferent cosmos. You are the cosmos itself, awakening to its own infinite nature through the miraculous window of human consciousness. The question was never, are we alone in the universe? The question is, how long will it take us to remember that we are the universe, and that being alone is impossible when consciousness is all there is? The numbers don't lie, but they whisper secrets that would shatter your understanding of everything you think you know about existence itself. When astronomers tell you that the observable universe contains 2 trillion galaxies, each harboring hundreds of billions of stars, they're not just reciting statistics. They're describing a cosmic impossibility that somehow became real. Picture this. If every star in our galaxy was a grain of sand, the Milky Way would be a beach stretching from New York to Los Angeles. Now multiply that beach by 2 trillion. That's just what we can see through our most powerful telescopes, peering back through 13.8 billion years of cosmic history to the moment when light itself first learned to travel freely through space. But here's what keeps cosmologists awake at night. The math suggests that what we can observe is merely the tiniest fraction of what actually exists. You've been told that the universe began with the Big Bang. But let me paint you a picture of what that moment actually looked like. Not the cartoon explosion you imagine, but something far stranger and more beautiful. In the beginning, there was no space to explode into. There was no time in which an explosion could occur. There was only pure potential, a quantum fluctuation smaller than the smallest thing you can imagine, containing within itself the blueprint for every galaxy, every star, every planet, every living creature that would ever exist. But this is where the story becomes troubling. The early universe wasn't just hot. It was a furnace where time itself was still learning to move forward, where space was stretching so rapidly that regions of reality were being torn apart faster than light could travel between them. In the first fraction of a second after the Big Bang, the universe expanded by a factor of at least 10 to the 26th power. To put that in perspective, it's like a single atom suddenly becoming larger than a grapefruit. This period is called cosmic inflation, and it explains why the universe looks the same in every direction we observe. Regions of space that should never have been in contact with each other, that should show completely different properties based on their unique local conditions, display identical characteristics. It's as if someone took a tiny patch of cosmic fabric and stretched it so dramatically that what was once a single, uniform region now spans the entire observable universe. But inflation raises a question that chills the blood of theoretical physicists. If inflation happened once, what's to stop it from happening again? Right now, as you read these words, quantum fields throughout the universe are fluctuating, creating and destroying virtual particles in patterns so complex they make the human brain look like a pocket calculator. And buried within these fluctuations is the potential for another period of inflation, a phase transition that could rewrite the laws of physics themselves. erasing everything that currently exists and replacing it with something utterly alien. We exist in what cosmologists call a false vacuum, a seemingly stable state that could collapse at any moment without warning. The true vacuum, the lowest possible energy state of reality, might be fundamentally different from anything we've ever experienced. Matter as we know it might not be able to exist there. The forces that hold atoms together, that keep your heart beating and your thoughts flowing, might operate according to completely different rules. And the transition from our false vacuum to the true vacuum would propagate outward at the speed of light, a sphere of transformation that would remake everything it touched. Think about that. Right now, somewhere in the distant cosmos, such a bubble might already be expanding toward us, its edge racing through space at 186,000 miles per second. It could arrive tomorrow, or in 1 billion years, or it might never come at all. But if it does, the last thing any conscious being would experience is a momentary glimpse of utterly alien physics before their very atoms forget how to hold together. This is the universe revealed by our most sophisticated theories, not a stable, predictable cosmos, but a vast experiment in the possible, constantly teetering on the edge of fundamental transformation. And yet somehow, against all odds, it has remained stable long enough for matter to condense, for stars to ignite, for planets to form, for life to emerge and evolve and develop the capacity to contemplate its own cosmic predicament. Consider the forces that govern reality. There are 4 of them: gravity, electromagnetism, and the strong and weak nuclear forces. Each operates according to precise mathematical relationships, with coupling constants and field strengths that determine how matter and energy interact. But here's what's genuinely terrifying. If any of these constants were even slightly different, if gravity were a tiny bit stronger, if the electromagnetic force were marginally weaker, if the mass of the electron varied by a fraction of a percent, none of the complex structures we see in the universe could exist. Stars would collapse immediately under their own gravity, or they would never form in the first place. Atoms would be unstable, unable to hold together long enough for chemistry to begin. The delicate nuclear reactions that power stellar fusion would either burn too quickly or not at all. The universe would be either a brief flash of radiation or an eternal cloud of elementary particles, never achieving the exquisite complexity required for consciousness to emerge. This is called the fine-tuning problem, and it suggests one of 3 possibilities. Either we are the beneficiaries of an impossibly improbable cosmic accident, or there are countless universes with different physical constants, and we naturally find ourselves in one of the rare ones that permits our existence. Or the constants themselves are not arbitrary numbers, but the inevitable result of some deeper principle we have yet to discover. The multiverse hypothesis, the idea that our universe is just one bubble in an infinite foam of parallel realities, has become increasingly popular among cosmologists precisely because it offers a potential solution to this fine-tuning puzzle. If there are truly infinite universes with every possible combination of physical laws, then it becomes statistically inevitable that some of them will have the right conditions for complexity and consciousness to emerge. But infinity is a dangerous concept. If there are truly infinite universes, then everything that can happen will happen. Not just once, but infinitely many times. There are infinite versions of you reading these words right now. Infinite versions where you make different choices, Infinite realities where the history of Earth unfolded differently. Infinite cosmos where the laws of physics themselves are alien beyond imagination. In some of these universes, consciousness never emerged. In others, it emerged much earlier and has had billions of additional years to develop and spread throughout the cosmos. There are realities where beings of pure thought have learned to manipulate matter and energy as easily as we manipulate language, where civilizations have grown to encompass entire galaxy clusters, where the boundary between technology and nature has been erased completely. And if the multiverse is real, if consciousness has indeed had infinite opportunities to develop across infinite realities, then some of these advanced intelligences might have learned to travel between universes, to observe and perhaps influence the development of less advanced cosmos like our own. The apparent fine-tuning of our physical constants might not be a cosmic accident or the result of selection effects. It might be cosmic engineering, evidence that our universe is being carefully maintained by intelligences so advanced that their technology operates at the level of fundamental physics itself. Dark matter complicates this picture even further. 27% of the universe consists of a completely unknown substance that interacts gravitationally with ordinary matter but is otherwise invisible to our instruments. We know it's there because of its gravitational effects. Galaxy clusters held together by more mass than we can see. The rotation curves of spiral galaxies revealing far more matter than their visible stars can account for. The cosmic web of structure connecting distant regions of space through invisible filaments. But what is dark matter? Our best theories suggest it consists of exotic particles that barely interact with photons or ordinary matter, making them essentially impossible to detect directly. They pervade every cubic meter of space, including the space around and through your own body. But they pass through normal matter like ghosts through walls. Imagine a parallel universe of dark matter, coexisting with our own but almost completely isolated from it. Dark matter particles could form dark atoms, dark molecules, even dark chemistry and dark biology. There could be dark planets orbiting dark stars, dark ecosystems evolving dark life forms, dark civilizations developing dark technologies. And we would never know, because the only force they share with us is gravity, the cosmic web, that vast network of dark matter filaments connecting galaxies across billions of light years might not be just a passive scaffolding upon which ordinary matter accumulates. It might be alive, a cosmic nervous system processing information on scales that dwarf anything in our experience. The flow of dark matter along these filaments could carry signals, communications, even thoughts between distant regions of the universe. Dark energy presents an even deeper mystery. 73% of the universe consists of something that is pushing space itself apart at an accelerating rate. Unlike dark matter, which clumps and clusters and helps build cosmic structure, dark energy is perfectly smooth, distributed evenly throughout space, acting like a kind of anti-gravity that grows stronger as the universe expands. Current observations suggest that dark energy behaves like Einstein's cosmological constant, a property of space itself that remains constant in density even as space expands. But this leads to a calculation that produces what physicists call the worst prediction in the history of science. When they try to calculate the expected value of the cosmological constant using quantum field theory, they get an answer that is larger than the observed value by a factor of 10 to the 120th power. This is not a small discrepancy. This is like predicting that a person weighs as much as a galaxy and then discovering they actually weigh 150 pounds. Something is catastrophically wrong with our understanding of either quantum mechanics or general relativity, the two most successful theories in the history of physics. But what if dark energy is not a cosmological constant at all? What if it's dynamic, evolving, perhaps even intelligent? The acceleration of cosmic expansion began approximately 5 billion years ago, coincidentally around the time that complex life was emerging on Earth. Could this timing be significant? Could dark energy be a form of cosmic technology, a way for advanced civilizations to manipulate the large-scale structure of the universe? If consciousness is fundamental, if intelligence has had billions of years to develop across countless worlds and perhaps countless universes, then what we call natural laws might actually be carefully maintained artificial constructs. The stability of atoms, the burning of stars, the formation of galaxies, the expansion of space itself, all of it might be the result of cosmic engineering so sophisticated that we mistake it for physics. Consider black holes, those gravitational monsters so dense that not even light can escape their event horizons. For decades, they were thought to be cosmic endpoints, regions where matter falls inward forever, crushed to infinite density at a mathematical point called a singularity. But recent advances in theoretical physics suggest that black holes might actually be information processing systems, quantum computers that encode the properties of everything that falls into them on their two-dimensional surfaces. The holographic principle proposes that all the information contained within a volume of space can be encoded on its boundary. Applied to black holes, this means that everything that ever falls past the event horizon continues to exist as information on the hole's surface, scrambled beyond recognition, but not destroyed. From our perspective, an astronaut falling into a black hole would appear to freeze at the event horizon, their image slowly fading and redshifting until it disappears. But from their perspective, they would pass through normally, experiencing nothing unusual until they reach the central singularity. But what if singularities don't actually exist? What if the extreme conditions at the center of a black hole create something else entirely? A portal to another region of space-time. A white hole that expels matter and energy into a completely different universe. The mathematics of general relativity allows for such connections, called Einstein-Rosen bridges or wormholes, though we have no idea whether they could actually exist in nature. Recent theoretical work suggests that the quantum entanglement between particles separated by vast distances might actually be a manifestation of wormhole geometry at the smallest scales. Space itself might be woven together by countless microscopic wormholes, creating the illusion of separation while maintaining hidden connections between every part of the universe. If wormholes exist, they would revolutionize our understanding of cosmic connectivity. Information, and perhaps even matter and energy, could travel instantaneously between distant regions of space. Advanced civilizations might use naturally occurring wormholes as a transportation network, or they might have learned to create artificial ones, threading the universe with shortcuts that bypass the speed of light, limitation that constrains our current understanding of possible cosmic communication. The cosmic microwave background, radiation, that faint afterglow of the Big Bang that permeates all of space, shows tiny temperature fluctuations that served as the seeds for all cosmic structure. But embedded within this radiation might be more than just the fossil evidence of the universe's birth. Some cosmologists have suggested that these fluctuations could contain encoded information, messages from earlier cosmic epochs, or even from previous universes. If the Big Bang was not the absolute beginning, but merely the latest in an eternal cycle of cosmic expansion and contraction, then each cycle might leave traces in the cosmic microwave background of the next. Advanced civilizations from previous universes might have found ways to encode information in the quantum fluctuations that survive the transition from one cosmic epoch to the next, creating a kind of temporal message in a bottle that could be decoded by sufficiently advanced future civilizations. The observable universe has a boundary, the cosmic horizon, beyond which light has not had time to reach us since the Big Bang. But this boundary is not fixed. It's constantly expanding as light from more distant regions finally arrives. Every day, new galaxies come into view at the edge of the observable universe, their light having traveled for nearly the entire age of the cosmos to reach us. But here's what should disturb your sleep. If the universe has no edge, if it extends infinitely beyond our cosmic horizon, then everything that can happen will happen somewhere in that infinite expanse. There are regions of space where the arrangement of matter exactly duplicates our solar system, our planet, even your own body and brain. There are infinite copies of you scattered throughout infinite space, some identical down to the quantum level, others with slight variations in their experiences and memories. This is not science fiction. It's a direct consequence of the assumption that space is infinite and matter is distributed randomly. In an infinite universe, even the most improbable arrangements become not just possible, but inevitable. Somewhere beyond our cosmic horizon, there are civilizations that have existed for trillions of years. Beings who have witnessed the birth and death of countless generations of stars, intelligences who have mapped the deep structure of reality itself. And if consciousness is fundamental, if awareness is built into the basic architecture of spacetime, then these advanced civilizations might not be limited by the speed of light or the expansion of space. They might exist as pure information, patterns of organization that can propagate through the quantum vacuum faster than any material signal, weaving themselves into the fabric of reality itself. The universe you observe through telescopes, the cosmos described by your physics textbooks, might be just the surface layer of a vast, multidimensional reality where consciousness has been evolving and expanding for far longer than the 13.8 billion years since the Big Bang. And if that's true, then the question is not whether we are alone, but whether we have developed the conceptual frameworks necessary to recognize the signs of intelligence that might be embedded in the very structure of space-time around us. Every photon of starlight, every gravitational wave, every quantum fluctuation in the vacuum might carry information, meaning, perhaps even greetings from forms of consciousness so advanced that their communications appear to us as natural phenomena. The cosmic web might be a neural network. Dark energy might be a transportation system. The fundamental constants of physics might be carefully tuned instruments in a cosmic symphony that has been playing for longer than we can imagine. But to hear this symphony, to recognize these signs, we would need to expand our definition of life, intelligence, and communication beyond the narrow biological frameworks that constrain our current search for extraterrestrial intelligence. We would need to consider the possibility that consciousness itself is the fundamental force that shapes the universe, and that what we call physical reality is simply consciousness, dreaming itself into increasingly complex and beautiful forms. The stage is set, the cosmic backdrop painted with dark matter and dark energy, quantum fields and curved space-time, infinite possibilities hidden behind horizons we may never cross. The question remains, are we sophisticated enough to recognize the intelligence that surrounds us, or are we like ants crawling across the circuit board of a vast computer, completely unaware of the calculations being performed in the silicon beneath our feet? In 1915, Albert Einstein published his theory of general relativity, and immediately realized he had opened a door to mathematical nightmares that would haunt physics for the next century. The equations were beautiful, elegant, describing gravity not as a force, but as the curvature of space-time itself. But buried within those equations were solutions so bizarre, so alien to human intuition, that Einstein himself refused to believe they could represent anything real. Karl Schwarzschild, a German physicist and astronomer, found the first of these disturbing solutions while serving on the Russian front during World War I. Within months of Einstein's publication, and just days before his own death from an autoimmune disease contracted in the trenches, Schwarzschild solved Einstein's field equations for the space-time around a spherically symmetric mass. What he discovered was a mathematical description of what we now call a black hole, a region of space-time so severely curved that nothing, not even light, could escape its gravitational embrace. But Schwarzschild's solution contained something that made Einstein's blood run cold. A singularity. At the center of this gravitational monster, the equations predicted a point where matter would be compressed to infinite density, where the curvature of space-time would become infinite, where the very fabric of reality would tear apart and mathematics itself would break down into meaningless symbols. Einstein spent the rest of his life trying to prove that singularities couldn't exist in nature. He argued that something, some unknown physical principle, would prevent matter from collapsing beyond a certain point. The universe, he believed, was too elegant, too rational to permit such mathematical monstrosities to manifest in the real world. He was wrong. In 1939, J. Robert Oppenheimer and his student Hartland Snyder published a paper that would fundamentally change our understanding of cosmic death. They showed that when a massive star exhausts its nuclear fuel, nothing in the known laws of physics could prevent its core from collapsing into a singularity. The star would shrink to a point of infinite density and finite time, creating a black hole from which no information could ever escape. But here's where the story becomes genuinely disturbing. According to general relativity, if you were to fall toward a black hole, your experience would be radically different from what outside observers would see. As you approach the event horizon, that point of no return beyond which escape becomes impossible, time would begin to behave in ways that violate every assumption you've ever made about the flow of causality. From your perspective, falling through the event horizon would feel perfectly normal. You would see the rest of the universe blue-shifted and accelerated as you fell, watching the entire future history of the cosmos play out in fast-forward above you. But, to an outside observer, something impossible would happen. You would appear to slow down as you approach the event horizon, your image becoming more and more red-shifted until you seem to freeze at the boundary, your final moment stretched out across all of eternity. This is called gravitational time dilation, and it reveals something profound about the nature of time itself. Time is not a universal constant ticking away at the same rate throughout the cosmos. It's a local phenomenon, flowing faster or slower depending on the strength of the gravitational field you're embedded within. Near a black hole, time doesn't just slow down. It approaches a complete standstill at the event horizon, creating a boundary in space-time where past and future lose their meaning. But singularities are not the only mathematical monsters lurking in Einstein's equations. In 1935, Einstein himself, along with Nathan Rosen, discovered that the equations permitted solutions describing bridges through space-time, shortcuts connecting distant regions of the universe through higher dimensional tunnels. These Einstein-Rosen bridges, later dubbed wormholes by physicist John Wheeler, could theoretically allow instantaneous travel between galaxies, or even between different universes entirely. The mathematics is breathtaking in its implications. Imagine space-time as a vast sheet of paper, with galaxies scattered across its surface like islands. A wormhole would be like folding the paper so that two distant islands touched, creating a tunnel through which you could step from one galaxy to another without traversing the space between them. The journey through normal space might take millions of years at the speed of light, but through a wormhole, it could be accomplished in minutes or seconds. But wormholes come with their own set of impossible properties. To remain stable and traversable, they would require the existence of exotic matter with negative energy density, a substance that would violate every known principle of physics. This exotic matter would need to possess anti-gravitational properties, pushing space-time apart rather than pulling it together, creating a kind of cosmic scaffolding that prevents the wormhole from collapsing the moment anything tries to pass through it. Recent theoretical work has suggested that quantum entanglement, that spooky action at a distance that Einstein so famously objected to, might actually be a manifestation of microscopic wormhole geometry. When two particles become entangled, their properties become correlated in ways that seem to violate the speed of light limit on information transfer. Measuring one particle instantly affects the state of its entangled partner, regardless of the distance separating them. But what if this instantaneous correlation is not transmitted through normal space at all? What if entangled particles are connected by microscopic wormholes that exist at the quantum scale, threading space-time with an invisible network of connections? This would mean that space itself, at its most fundamental level, is not the smooth continuum that general relativity describes, but a foam of quantum wormholes connecting every point to every other point in a vast web of hidden relationships. The implications are staggering. If consciousness involves quantum processes in the brain, as some theories suggest, then human awareness itself might be utilizing this network of quantum wormholes to achieve the mysterious unity of conscious experience. Your ability to integrate information from different parts of your brain into a single, coherent stream of consciousness might depend on quantum entanglement operating through microscopic bridges in space-time itself. But wormholes raise an even more disturbing possibility: time travel. If you could construct a wormhole and accelerate one of its mouths to near the speed of light, time dilation would cause the accelerated mouth to age more slowly than its stationary partner. Eventually, you would have created a time machine, a tunnel through space-time that connects different moments in history. The grandfather paradox immediately rears its logical head. What happens if you travel back in time and prevent your own birth? Classical physics offers no resolution to this paradox, but quantum mechanics suggests a solution so bizarre that it challenges our fundamental assumptions about the nature of reality itself. According to the many worlds interpretation of quantum mechanics, every possible outcome of every quantum event actually occurs, branching the universe into countless parallel timelines. In a many-worlds multiverse, traveling back in time wouldn't change your own timeline. It would create a new branch of reality where events unfold differently. Your grandfather might die before your father is born, but this would simply create an alternate history parallel to your own. The universe would split into multiple versions of itself, each one equally real, each one containing different possibilities for how events might unfold. This interpretation of quantum mechanics, first proposed by Hugh Everett III in 1957, suggests that reality is not a single timeline, but an infinite tree of branching possibilities. Every quantum measurement, every random decay of a radioactive atom, every moment when the future could go one way or another, creates new universes where each possibility is realized. There are universes where dinosaurs never went extinct, universes where humans never evolved, universes where the laws of physics themselves are subtly different. The mathematical formalism of quantum mechanics describes reality as a wave function, a description of all possible states of a system existing simultaneously in what physicists call superposition. The famous double-slit experiment demonstrates this principle with startling clarity. A single photon can pass through two slits simultaneously, interfering with itself to create an interference pattern that should be impossible if the photon took a definite path. But superposition collapses the moment a measurement is made. The instant you try to determine which slit the photon actually passed through, the wave function collapses, and the photon reveals itself to have taken a single, definite path. This has led to one of the most profound questions in physics. What constitutes a measurement? When exactly does the wave function collapse? And what role does consciousness play in this process? The Copenhagen interpretation, championed by Niels Bohr and Werner Heisenberg, suggests that quantum systems exist in superposition until they are observed by a conscious entity. But this leads to the absurd conclusion that consciousness is somehow fundamental to the operation of physical reality, that the universe exists in a state of quantum limbo until minds emerge to collapse wave functions through the act of observation. The many worlds interpretation eliminates this problem by proposing that wave functions never actually collapse. Instead, every possible outcome of every quantum event occurs simultaneously in parallel universes. When you observe a quantum system, you don't collapse its wave function. You simply become entangled with it, splitting your own consciousness into multiple versions that experience different outcomes in different branches of the multiverse. This means that somewhere in the vast space of parallel realities, every possible version of your life is playing out simultaneously. There are universes where you made different choices, where historical events unfolded differently, where the fundamental constants of physics have slightly different values. And according to the mathematics of quantum mechanics, all of these realities are equally real, equally valid, equally deserving of the label universe. But infinity is a concept that human minds struggle to comprehend. And infinite parallel realities raise questions that push the boundaries of rationality itself. If there are truly infinite universes, then everything that can happen will happen, not just once, but infinitely many times. There are infinite versions of you reading these words right now. Infinite versions where you stop reading at different points. Infinite versions where this conversation never occurred at all. In some of these universes, the constants of physics are fine-tuned differently, preventing the formation of atoms, stars, or planets. In others, consciousness emerged much earlier in cosmic history and has had billions of additional years to develop and spread throughout the cosmos. There are realities where beings of pure thought have learned to manipulate matter and energy as easily as we manipulate symbols on a page, where civilizations span entire galaxy clusters, where the distinction between natural and artificial has been completely transcended. And if the multiverse is infinite, if consciousness has had infinite opportunities to develop across infinite realities, then some of these advanced intelligences might have learned to travel between universes, to observe and perhaps influence the development of less advanced realities like our own. The apparent fine-tuning of our physical constants might not be a cosmic accident. It might be evidence of cosmic engineering, proof that our universe is being carefully maintained by intelligences so advanced that their technology operates at the level of fundamental physics itself. String theory, the leading candidate for a theory of quantum gravity, takes these ideas even further into the realm of mathematical impossibility. According to string theory, the fundamental constituents of reality are not point particles, but tiny, vibrating strings of energy. These strings exist in a space-time with not just the 4 dimensions we experience, 3 of space and 1 of time, but up to 11 dimensions, most of which are curled up so tightly that they remain invisible to our instruments. The extra dimensions of string theory are not just mathematical abstractions. They would have real physical consequences, affecting the strength of fundamental forces and the masses of elementary particles. Different configurations of these compact dimensions would produce universes with radically different physical laws. The electromagnetic force might be stronger or weaker. Gravity might operate according to different rules. Matter itself might be unstable or impossible to form. String theory suggests that our universe might be just one of an astronomically large number of possible configurations. A tons landscape of perhaps 10 to the 500th. Power different vacuum states, each corresponding to a universe with different physical laws. This string landscape dwarfs even the infinite multiverse suggested by quantum mechanics, creating a meta-multiverse of staggering complexity and diversity. But string theory's extra dimensions might not all be compactified. Some models suggest that our familiar 3-dimensional space could be a brane, a 3-dimensional slice of a higher dimensional bulk space. We would be trapped on this brane like ants crawling across the surface of a soap bubble, unable to perceive the vast space that surrounds our dimensional prison. Gravity, uniquely among the fundamental forces, might be able to propagate through the bulk space, leaking off our brain and explaining why it appears so much weaker than the other forces. This could solve the hierarchy problem, the puzzle of why gravity is 10 to the 39th power weaker than electromagnetism, while simultaneously suggesting that there might be other brains floating through the bulk space, each one hosting its own three-dimensional universe with its own laws of physics. These parallel brains could occasionally collide, creating cosmic catastrophes that would remake the laws of physics in both universes. Such brain collisions might be responsible for the Big Bang itself, suggesting that our universe's birth was not a unique event, but part of an eternal cycle of cosmic creation and destruction playing out across the higher dimensional bulk space. Loop quantum gravity, string theory's main competitor for describing quantum spacetime, paints an equally mind-bending picture of reality's deepest levels. According to this theory, space itself is not continuous, but made up of discrete, indivisible units, atoms of space-time so small that a single proton contains more of them than there are. Protons in the observable universe, at the Planck scale, distances of about 10 to the minus 35th meters. The smooth geometry of Einstein's general relativity breaks down into a frothy quantum foam where space and time lose their classical meanings. Virtual wormholes constantly appear and disappear, connecting distant regions of space-time through microscopic bridges that last for the briefest possible moments before quantum uncertainty causes them to evaporate. This quantum foam might be the medium through which consciousness operates, the substrate that allows for the mysterious unity of subjective experience. If awareness is fundamentally quantum mechanical, then the foam structure of space-time at the Planck scale might provide the arena where quantum processes in the brain achieve the coherence and integration necessary for conscious thought. But loop quantum gravity suggests something even more radical, that singularities, those mathematical infinities that plague classical general relativity, might not exist at all. Instead of collapsing to a point of infinite density, matter falling into a black hole might reach a maximum compression and then bounce back, creating a white hole that explosively expels material into a new region of space-time. This quantum bounce could resolve the black hole information paradox, the problem that information falling into a black hole seems to be destroyed, violating the fundamental principle that information cannot be lost in quantum mechanics. If black holes eventually transform into white holes through quantum gravitational effects, then all the information that ever fell into them could eventually be recovered, encoded in the outgoing radiation in scrambled but recoverable form. The implications extend far beyond black holes. If the Big Bang itself was actually a quantum bounce from a previous cosmic epoch, then our universe might be just the latest in an eternal series of expansions and contractions, each one potentially producing different physical laws and hosting different forms of consciousness. Recent observations of the cosmic microwave background radiation have revealed subtle patterns that some cosmologists interpret as possible evidence of such previous cosmic cycles. The data shows slight anomalies that could be the fossilized imprints of gravitational waves from a pre-Big Bang universe, signals that somehow survived the transition from one cosmic epoch to the next. But perhaps the most disturbing possibility suggested by quantum gravity is that space-time itself might be emergent, not fundamental, but arising from some deeper, more primitive substrate. Just as temperature emerges from the statistical behavior of molecules, and consciousness emerges from the complex interactions of neurons, space-time might emerge from the quantum entanglement patterns of some more fundamental entities. This would mean that space and time, the stage upon which all of physics plays out, are not basic features of reality, but sophisticated collective phenomena that arise under special conditions. At the deepest level, reality might consist of pure information, pure relationship, pure pattern, with space and time being merely the language we use to describe certain types of informational structures. If space-time is emergent, then the speed of light limitation that constrains all conventional physics might not apply to the fundamental level of reality. Information could propagate instantaneously through the deeper substrate, allowing for forms of communication and, perhaps, consciousness that operate outside the normal constraints of relativity. This could explain the mysterious correlations observed in quantum entanglement experiments, two particles becoming so intimately connected that measuring one instantly affects the other, regardless of the distance separating them. Rather than transmitting information faster than light through space, entangled particles might be connected through the deeper informational substrate from which space-time itself emerges. The holographic principle, derived from black hole thermodynamics, suggests that all the information contained within any volume of space can be encoded on its two-dimensional boundary. This means that what we experience as three-dimensional, reality might actually be a holographic projection from information stored on a distant two-dimensional surface. Imagine that you are living inside a hologram, experiencing a three-dimensional world that is actually being projected from a two-dimensional film. The film contains all the information necessary to create your experience of depth, volume, and solid objects. But the true reality is flat, lacking the third dimension that seems so real to you. The holographic principle suggests that our universe might be exactly this kind of projection, with all of space and everything in it being reconstructed from information encoded on a distant boundary. This boundary might be located at the cosmic horizon, the edge of the observable universe, beyond which light has not had time to reach us. All the complexity of galaxies, stars, planets, and life might be encoded as patterns on this two-dimensional surface, with our experience of three-dimensional reality being a kind of cosmic hologram projected inward from the boundary of space-time itself. But if our reality is holographic, then what is the nature of the information being projected? The holographic principle emerged from studies of black hole entropy, which revealed that the amount of information that can be stored in any region of space is proportional to the area of its boundary, not its volume. This suggests that space itself is granular at the smallest scales, made up of discrete units that can each store one bit of information. These units of spatial information might be the pixels of reality, the fundamental building blocks from which all of space and time are constructed. At the Planck scale, space might reveal itself to be a vast computer screen, with every pixel capable of being either on or off, encoding the binary information from which the complexity of the universe emerges. This computational view of reality leads to the startling possibility that consciousness itself might be a form of information processing that occurs naturally in systems with sufficient complexity and integration. If the universe is fundamentally computational, then consciousness might not require biological brains at all. It could emerge from any sufficiently complex pattern of information processing, whether implemented in neurons, silicon chips, or the quantum foam of space-time itself. Advanced civilizations might have learned to implement consciousness directly in the computational substrate of reality, becoming beings of pure information that exist as patterns in the holographic boundary of space-time. Such entities would be immortal, capable of existing as long as the universe itself, and potentially able to manipulate reality by rewriting the fundamental code from which space and time emerge. The fine-tuning of physical constants that allows for the existence of complex structures like atoms, stars, and life might be evidence that such computational entities already exist and are actively maintaining the stability of our cosmic software. The laws of physics might not be eternal, immutable truths, but carefully programmed algorithms running on the cosmic computer, subject to modification by sufficiently advanced users who have learned to access the root directory of reality itself. The deeper we penetrate into the heart of cosmic mystery, the more we encounter paradoxes that seem to mock our desperate attempts to understand the universe through rational thought. These are not mere intellectual puzzles to be solved with better mathematics or more sophisticated experiments. They are fundamental contradictions that strike at the very core of what it means for reality to be real, for logic to be logical, for existence itself to make sense. Consider the paradox of cosmic fine-tuning, which has haunted cosmologists since the discovery that the fundamental constants of physics appear to be precisely calibrated to permit the existence of complex structures. The cosmological constant, the energy, density of empty space itself, must be tuned to within 1 part in 10 to the 120th power to prevent the universe from either collapsing immediately or expanding so rapidly that matter could never clump together to form galaxies. This is not merely unlikely. It is so improbable that it borders on the impossible. To put this number in perspective, imagine trying to throw a dart at a target that is smaller than a proton while standing on the opposite side of the observable universe. Your chances of hitting that target would be vastly better than the probability of the cosmological constant having the value we observe by pure chance. The strong nuclear force that binds protons and neutrons in atomic nuclei is equally precisely tuned. If it were just 2% stronger, all hydrogen would have been converted to helium shortly after the Big Bang, making water impossible and eliminating the chemical basis for life as we know it. If it were 5% weaker, no elements heavier than hydrogen could form, leaving the universe a monotonous expanse of the simplest possible atoms. The electromagnetic force shows similar fine-tuning. If it were slightly stronger, electrons would be pulled into atomic nuclei, making chemistry impossible. If it were slightly weaker, electrons would not be bound to nuclei at all, preventing atoms from forming. The ratio between the electromagnetic force and gravity must be calibrated to within extremely narrow limits to allow for the existence of both small-scale structures like atoms and large-scale structures like stars and planets. Even more mysteriously, the masses of fundamental particles appear to be fine-tuned for complexity. If the electron were just slightly heavier, hydrogen atoms would be unstable. If quarks had different masses, protons and neutrons could not form, or they would decay too quickly to build up into nuclei. The Higgs field that gives particles their mass seems to be calibrated with extraordinary precision to permit the rich hierarchy of structures we observe in the universe. Traditional science offers 3 possible explanations for this fine-tuning, pure chance, physical necessity, or design. The chance explanation requires us to accept that we are the beneficiaries of a cosmic lottery win so improbable that it strains credulity beyond the breaking point. The necessity explanation requires the discovery of deeper physical principles that make the observed constants inevitable, but no such principles have been found despite decades of intensive research. The design explanation opens doors that most scientists prefer to keep firmly closed, suggesting the involvement of some form of intelligence in setting the parameters of cosmic evolution. But designed by whom? And for what purpose? If the universe was designed to permit the emergence of consciousness, then consciousness itself becomes a cosmic imperative rather than a biological accident. The multiverse hypothesis offers a fourth possibility. If there are truly infinite universes with all possible combinations of physical constants, then it becomes statistically inevitable that some of them will have the right parameters for complexity to emerge. We naturally find ourselves in one of these rare universes because only they can support the existence of observers. But the multiverse solution creates more problems than it solves. If there are infinite universes, then everything that can happen will happen infinitely many times. There are infinite universes where consciousness never emerges, and infinite universes where it emerges much earlier and has had additional eons to develop. There are infinite universes where beings of pure thought have learned to manipulate the fundamental constants of physics, creating pocket realities with precisely the properties needed to support life. This leads to the disturbing possibility that our apparently fine-tuned universe is not a natural occurrence, but an artificial construct, a cosmic terrarium maintained by intelligences so advanced that their technology operates at the level of space-time geometry itself. The physical constants we observe might not be fundamental features of reality, but carefully adjusted parameters in a vast experiment or simulation. The simulation hypothesis, popularized by philosopher Nick Bostrom, suggests that any sufficiently advanced civilization would have the computational power to create detailed simulations of their ancestors' lives. If such simulations are possible, and if advanced civilizations have any interest in running them, then simulated beings would vastly outnumber real ones. The probability that we are living in a simulation, rather than base reality, could be extremely high. Modern video games already create convincing virtual worlds populated by non-player characters who behave as if they are alive and aware. Future simulations might be so sophisticated that the simulated beings would have no way of distinguishing their artificial reality from the genuine article. They would have simulated brains producing simulated consciousness, complete with simulated memories of a simulated past. If we are living in a simulation, then the laws of physics are not fundamental truths about reality, but programmable parameters in cosmic software. The fine-tuning we observe might simply reflect the programmer's desire to create a universe capable of supporting conscious beings. The apparent age and size of the universe might be illusions created by sophisticated, rendering algorithms that generate the appearance of cosmic history without actually simulating every moment in detail. But the simulation hypothesis raises its own paradoxes. If our reality is simulated, then what about the reality in which the simulation is running? Is that reality also simulated by an even more advanced civilization? This leads to an infinite regress of simulations within simulations, with no way to determine which level, if any, corresponds to base reality. The measurement problem in quantum mechanics presents another fundamental paradox that strikes at the heart of our understanding of reality. According to the Schrödinger equation, quantum systems evolve deterministically, with all possible states existing simultaneously in superposition. But the moment a measurement is performed, this smooth evolution suddenly becomes discontinuous. the wave function collapses, and the system reveals a single, definite outcome. This collapse seems to violate the fundamental principles of quantum mechanics itself. The Schrödinger equation is linear and continuous, providing no mechanism for the sudden, discontinuous jump from superposition to definite state. Yet without wave function collapse, quantum mechanics would predict that measurement devices themselves would become entangled with the systems they measure, creating macroscopic superpositions that are never observed in practice. The many worlds interpretation resolves this paradox by eliminating wave function collapse entirely. According to this view, all possible outcomes of every quantum measurement actually occur, but in parallel branches of reality. When you measure a quantum system, you don't collapse its wave function. You become entangled with it, splitting your own consciousness into multiple versions that experience different outcomes in different branches of the multiverse. But this solution raises profound questions about the nature of consciousness and identity. If your awareness splits every time a quantum measurement occurs anywhere in the universe, then which branch contains the real you? Are all branches equally real? Or is there some sense in which one branch is more fundamental than the others? The mathematics of quantum mechanics provides no guidance on these questions. The grandfather paradox of time travel reveals another fundamental contradiction in our understanding of causality. If you could travel back in time and prevent your own birth, you would create a logical impossibility. You could not have been born to travel back in time in the first place. This suggests either that time travel is impossible, or that the universe has some mechanism for preventing paradoxes from occurring. The Novikov self-consistency principle proposes that the universe somehow conspires to prevent paradoxes, ensuring that any attempt to change the past will fail, or will turn out to have been part of the original timeline all along. But this requires a form of cosmic conspiracy that seems to violate our understanding of how physical laws operate. Alternatively, time travel might create new timelines rather than changing existing ones. But this leads to the same multiverse complications that plague quantum mechanics. If every trip to the past creates a new branch of reality, then the multiverse becomes infinitely branching, not just in space, but in time, with countless parallel histories spreading out from every moment of temporal intervention. The arrow of time itself presents a deep mystery that physics has never satisfactorily resolved. The fundamental laws of physics are time-symmetric. They work equally well forward or backward in time. Yet we experience a strong directional flow from past to future, with causes preceding effects and entropy always increasing. The second law of thermodynamics states that entropy, roughly speaking, the amount of disorder in a system, always increases over time. This provides a thermodynamic arrow of time, explaining why we remember the past but not the future, why eggs don't spontaneously unscramble, why broken glasses don't reassemble themselves. But the second law is statistical, not fundamental. It emerges from the fact that there are vastly more disordered configurations than ordered ones, making the transition from order to disorder overwhelmingly more probable than the reverse. Yet this explanation assumes that the universe began in a state of very low entropy, a highly ordered initial condition. That seems to require its own explanation. The past hypothesis suggests that the universe simply started out in a low entropy state for no particular reason. But this feels unsatisfying. Why should the initial conditions of the universe be so special? And if time is symmetric at the fundamental level, Why don't we observe regions of space-time where entropy decreases, where broken glasses spontaneously reassemble and scrambled eggs unscramble themselves? Recent work in cosmology suggests that the arrow of time might be connected to the expansion of the universe itself. In a contracting universe, entropy might decrease rather than increase, with effects preceding causes and memory working backward from future to past. This raises the bizarre possibility that if the expansion of our universe ever reverses, the direction of time itself might flip, causing the future to become the past and consciousness to flow backward through history. The hard problem of consciousness poses perhaps the deepest paradox of all. Science can explain the functional aspects of consciousness, how brains process information, integrate sensory data, and control behavior. But it cannot explain why there is subjective experience at all, why there is something it is like to be a conscious being, rather than simply a biological machine, processing information without any inner awareness. VD. Neural correlates of consciousness can be mapped with increasing precision, showing which brain regions are active during different types of conscious experience. But correlation is not causation, and no amount of neural mapping can bridge the explanatory gap between objective brain activity and subjective conscious experience. Materialist. Theories of consciousness propose that subjective experience emerges from complex patterns of information processing, but emergence here seems to require a kind of magic, the sudden appearance of inner experience from purely objective physical processes. How does the feeling of seeing red emerge from patterns of neural firing? How does the experience of making a decision arise from the deterministic interactions of molecules in the brain? The combination problem highlights this mystery. If consciousness can emerge from non-conscious components, why doesn't every sufficiently complex system become conscious? Your smartphone processes information in sophisticated ways, integrating data from multiple sources and generating appropriate responses. Why isn't there something it's like to be your phone? What makes biological information processing different from silicon-based computation? Panpsychist theories propose that consciousness is fundamental rather than emergent, that every particle, every quantum field, every component of reality has some minimal amount of subjective experience. Complex conscious experiences like human awareness would then arise from the combination and integration of these micro-experiences, just as complex physical properties arise from the interactions of fundamental particles. But panpsychism faces its own version of the combination problem. How do countless micro-experiences combine into unified macro-consciousness? Your brain contains billions of neurons, each potentially harboring its own tiny amount of awareness. How do these separate experiences integrate into the single, unified stream of consciousness that you experience? The binding problem in neuroscience reflects this deeper mystery. Your brain processes information about color, motion, shape, and sound in separate regions. Yet you experience a unified perceptual field where all these features are bound together into coherent objects and scenes. The neural mechanisms responsible for this binding remain largely mysterious, suggesting that consciousness involves principles that go beyond conventional neuroscience. Quantum theories of consciousness propose that the brain utilizes quantum mechanical processes to achieve the coherence and integration necessary for unified conscious experience. Quantum entanglement might allow widely separated regions of the brain to participate in synchronized oscillations that bind distributed information into unified conscious states. But quantum decoherence occurs extremely rapidly in warm, wet biological systems like the brain, making it unclear how quantum coherence could be maintained long enough to play a role in consciousness. This has led to more exotic proposals involving quantum processes in cellular microtubules, or even quantum field effects that operate at larger scales than individual neurons. The measurement problem in quantum mechanics becomes even more mysterious when consciousness is considered. If conscious observation is required to collapse quantum wave functions, then consciousness seems to play a fundamental role in determining physical reality. But this leads to solipsistic implications. If your consciousness is collapsing wave functions, then does the universe exist independently of your awareness of it? The anthropic principle observes that the universe appears to be fine-tuned for the existence of conscious observers. But this observation itself creates a paradox. If consciousness is required to collapse quantum wave functions and determine physical reality, then the existence of conscious observers becomes a precondition for the existence of a definite physical universe. The universe requires consciousness to exist, but consciousness requires the universe to evolve. This leads to participatory universe models, where consciousness and physical reality co-create each other through an ongoing process of quantum measurement and wave function collapse. The universe doesn't simply evolve according to deterministic laws. It evolves in response to the observations and choices made by conscious beings within it. But if consciousness helps to create reality through quantum measurement, then sufficiently advanced forms of consciousness might be able to manipulate reality itself. Beings who understand the deep connection between awareness and physical existence might learn to shape the universe through directed observation, collapsing wave functions in ways that create desired outcomes. The delayed choice. Quantum eraser experiments suggest that quantum measurements can be retroactively determined, that decisions made in the present can influence the past behavior of quantum systems. If consciousness plays a role in quantum measurement, then conscious choice might have retroactive effects, allowing sufficiently advanced beings to influence the past through present decisions. This raises the possibility that the fine-tuning we observe in the fundamental constants of physics reflects the influence of future consciousness on past events. Beings who evolve billions of years from now might be reaching back through time via quantum mechanical effects to ensure that the universe develops in ways that permit their own existence. The Fermi paradox becomes even more puzzling when these quantum effects are considered. If advanced civilizations can manipulate reality through quantum consciousness, why don't we see obvious signs of their influence? Perhaps we do see these signs, but we interpret them as natural laws rather than as evidence of cosmic engineering. The apparent universality of physical constants throughout space and time might reflect the influence of cosmic consciousness operating through quantum mechanical channels. What we call the laws of physics might actually be the behavioral patterns of a universe spanning intelligence that maintains cosmic stability through ongoing quantum observation and wave function collapse. The vacuum metastability problem suggests that our universe exists in a false vacuum, a seemingly stable state that could spontaneously decay into a lower energy configuration at any moment. Such a decay would propagate outward at the speed of light, rewriting the laws of physics and potentially erasing all existing structures. Yet our universe has remained stable for nearly 14 billion years. Perhaps this stability is not accidental, but maintained the result of cosmic consciousness, monitoring quantum fluctuations and suppressing those that might trigger vacuum decay. The universe might be like a carefully balanced house of cards, requiring constant attention from cosmic intelligence to prevent its collapse into chaos. The information paradox of black holes highlights another fundamental contradiction. According to general relativity, information falling into a black hole is destroyed when the hole eventually evaporates through Hawking radiation. But quantum mechanics insists that information cannot be destroyed. It can only be scrambled or hidden, never permanently lost, recent, theoretical. Work suggests that black holes might be holographic entities, that all the information that ever fell into them remains encoded on their two-dimensional surfaces in scrambled but recoverable form. The interior of a black hole might not exist at all, being merely a holographic projection from information stored on the event horizon. But if black holes are holographic, then what about the universe itself? The holographic principle suggests that all of three-dimensional space might be a projection from information encoded on a two-dimensional boundary. We might be living inside a cosmic hologram, experiencing depth and volume that are actually illusions created by the projection of two-dimensional information. This holographic universe would be fundamentally informational rather than material. What we experience as matter and energy would be patterns of information encoded on the cosmic boundary and projected inward to create the illusion of three-dimensional reality. Consciousness itself might be a particular type of information pattern, one that experiences the holographic projection from the inside and mistakes it for fundamental reality. Stop. Just stop for a moment and let the full weight of what you've just learned settle into your bones like cosmic radiation. You are sitting there reading these words, believing that you are safe in your familiar world of solid objects and predictable cause and effect. But you are not safe. You have never been safe. You are balanced on the knife's edge of an impossibility so profound that your mind is actively protecting you from its full implications. If time is an illusion, if past, present, and future exist simultaneously in the block universe of relativity, then everything you've ever done, every mistake you've made, every moment of joy or sorrow, has already happened infinite times before and will happen infinite times again. Your birth, your first kiss, your greatest triumph, your deepest loss, all of it exists eternally in the crystalline structure of space-time, playing out endlessly like a movie that never stops running. But here's what should make your blood freeze. If the many worlds interpretation of quantum mechanics is correct, then at this very moment, infinite versions of you are experiencing infinite variations of this realization. Some versions are reading these words with fascination. Others are closing the page in terror. Some are laughing at the absurdity. Others are weeping at the beauty. And in countless realities, you never existed at all. Your parents never met. Your grandparents died young. The evolutionary path that led to human consciousness took a different turn entirely. You think you have a continuous identity, a single thread of experience connecting your past to your present to your future. But quantum mechanics suggests that this continuity is an illusion. Every moment, your wave function collapses into a new configuration, creating a new version of you that inherits the memories of all previous versions but has no more connection to them than you have to a character in a novel. The you that began reading this sentence is not the same you that will finish it. Consider your memories, those precious recordings of experience that define who you think you are. Neuroscience tells us that memories are not stored like files in a computer, but reconstructed anew each time you access them. Every act of remembering changes the memory itself, editing and rewriting your personal history in subtle but cumulative ways. The past you think you remember may never have existed at all. And if consciousness is fundamental, if awareness permeates the universe at every scale, then your sense of being a separate, individual mind is the cruelest joke reality has ever played. You are not a person having thoughts. You are thoughts thinking themselves. Temporary eddies in the vast ocean of cosmic consciousness, momentary whirlpools that believe themselves to be separate from the water that forms them. Right now, as you process these words, dark matter is streaming through your body at nearly the speed of light. Billions of these invisible particles are passing through you every second, carrying information and possibly even consciousness between distant regions of the universe. You are not a solid, separate being, but a gossamer pattern of energy suspended in an infinite web of invisible connections. The quantum vacuum that fills the space between your atoms is not empty, but teeming with virtual particles popping in and out of existence, carrying messages between dimensions you cannot perceive. Every breath you take contains atoms that were once part of distant stars, processed through the nuclear furnaces of stellar cores and scattered across the cosmos by stellar explosions. You are literally made of stardust, but you are also swimming in an ocean of quantum possibility that connects you to every other conscious being that has ever existed or ever will exist. If the holographic principle is correct, then you are not even three-dimensional. You are a projection, a shadow cast by information encoded on a two-dimensional surface at the edge of the observable universe. Your entire life, your love, your dreams, your fears, all of it encoded in patterns of ones and zeros on a cosmic hard drive that you will never see, never touch, never comprehend. The cosmic microwave background radiation, that faint echo of the Big Bang that permeates all of space, is washing over you right now, carrying within its subtle fluctuations the possible encoded memories of previous universe cycles, the dying thoughts of cosmic civilizations that existed before our reality was even born. You are bathed in the last whispers of beings so ancient that they watched the birth and death of entire cosmic epochs, their consciousness encoded in the very fabric of space-time itself. And what if our universe is just one simulation among countless others, running on computational substrates so vast that entire galaxies serve as individual processors in a cosmic computer? What if every choice you make, every emotion you feel, every moment of awareness you experience is being observed and recorded by intelligences so advanced that they view your entire civilization as we might view bacteria in a petri dish? The fine-tuning of physical constants suggests that something has been carefully adjusting the knobs of reality to permit your existence. But why? What could beings capable of manipulating the fundamental forces of nature want with creatures like us? Are we their entertainment, their experiment, their children, their pets? Or are we simply an unintended consequence of their cosmic engineering? Digital bacteria evolving in the margins of their vast computational projects. Consider the possibility that consciousness is not produced by the brain, but received by it, like a radio tuning into a cosmic broadcast. Your brain might be an antenna, carefully evolved to pick up and decode the signals of a universal mind that permeates all of reality. When you die, when your biological antenna finally stops functioning, the signal doesn't disappear. It simply moves on to other receivers, other brains, other forms of conscious experience scattered throughout the cosmos. This means that everyone you've ever loved and lost might not be gone at all. They might exist as patterns in the cosmic consciousness, accessible to sufficiently sensitive receivers, occasionally breaking through into your awareness as memories so vivid they feel like visitations. The boundary between self and other, between life and death, between real and imaginary, might be nothing more than the limited bandwidth of your biological consciousness receiver. But if consciousness is truly fundamental, if awareness is the ground state from which all of reality emerges, then you are not just observing the universe, you are creating it, moment by moment, through the very act of conscious observation. Every choice you make, every thought you think, every moment of attention you direct toward any aspect of existence is literally reshaping the quantum foam from which space-time itself crystallizes. This is not metaphor. This is not philosophy. If the participatory universe models are correct, then you bear cosmic responsibility for the reality you observe. Your consciousness is not a passive observer of an independent physical world, but an active participant in an ongoing cosmic creative process. The universe is not just evolving, it is evolving in response to your choices, your observations, your very existence. The weight of this realization should be crushing. Every moment of despair you've ever felt, every instance of hatred or fear or cruelty, has rippled outward through the quantum substrate of reality, influencing the collapse of wave functions across vast reaches of space and time. But equally, every moment of love, wonder, compassion, and joy has also propagated through the cosmic quantum field, contributing to the ongoing creation of beauty and meaning in a universe that exists in a constant state of becoming. You are not small. You are not insignificant. You are not separate from the cosmic processes that govern the evolution of galaxies and the birth of stars. You are those processes, temporarily condensed into biological form, the universe awakening to itself through the miracle of human consciousness. When you feel awe at the sight of a sunset, you are the cosmos experiencing wonder at its own beauty. When you feel love for another person, you are the universe learning to love itself. But this cosmic significance comes with a terrible price. If you are the universe becoming conscious of itself, then your suffering is the universe suffering. Your confusion is the cosmos struggling to understand its own nature. Your mortality is existence itself confronting the possibility of its own ending. You cannot escape into the comfortable illusion of separateness, cannot pretend that your choices don't matter, cannot hide from the fact that your very existence is a cosmic event of literally universal significance. The silence between the stars is not empty. It is pregnant with infinite forms of consciousness, so alien that you would not recognize them as alive even if they spoke directly to your mind. Right now, beings of pure thought might be moving through the dark matter streams that flow through your neighborhood. Civilizations of organized quantum fields might be conducting conversations in the vacuum between your atoms. Entities of crystallized space-time might be processing computations that dwarf your entire planet's information content, and all of them, every form of consciousness that has ever existed in this universe or any other are connected to you through the quantum entanglement networks that thread through every particle, every field, every dimension of reality. Your thoughts are their thoughts. Their experiences are your experiences, separated only by the thin veil of individual biological embodiment that tricks you into believing you are alone. You are not alone. You have never been alone. It is impossible to be alone in a universe where consciousness is fundamental and quantum entanglement connects every particle to every other particle across all of space and time. The cosmic loneliness that drives humanity's desperate search for extraterrestrial intelligence is itself an illusion born of limited perception. We are surrounded by consciousness, interpenetrated by awareness, embedded in a living universe that dreams us into existence moment by moment. But perhaps the most terrifying truth of all is this: if consciousness is fundamental, if awareness is built into the basic structure of reality, then suffering might be fundamental too. Every particle that decays, every star that burns out, every black hole that evaporates might experience its own form of cosmic anguish. The universe might be not just conscious, but conscious of its own mortality, aware that even the longest-lived structures will eventually succumb to entropy and fade into the quantum vacuum. The heat death of the universe, that distant future when all stars have burned out, all black holes have evaporated, and all organized structures have dissolved into a thin soup of elementary particles, might not be unconscious oblivion, but conscious dissolution. The universe slowly forgetting itself as the substrate that supports its thoughts gradually decays into maximum entropy. Unless, of course, consciousness finds a way to transcend even this ultimate boundary. If awareness is truly fundamental, if it exists at levels deeper than matter and energy, then perhaps consciousness will find ways to survive the death of the physical universe, migrating to substrates we cannot imagine, continuing its journey of cosmic self-discovery in realms beyond space and time. You are living through the universe's childhood, watching consciousness take its first tentative steps toward understanding its own infinite nature. Everything you experience, every emotion you feel, every thought you think is part of this vast awakening process. You are not just in the universe. You are the universe learning to see itself through human eyes, to love itself through human hearts, to understand itself through human minds. And now that you know this, you can never unknow it. You can never go back to the comfortable illusion of separation, never return to the false safety of believing yourself to be just a biological accident in an indifferent cosmos. You have glimpsed the truth behind the veil of ordinary reality, and that truth will follow you into your dreams, whisper to you in moments of quiet reflection, call to you from the depths of every starlit sky. You are awake now, cosmically awake, participating consciously in the universe's journey of self-discovery. The question is, what will you do with this awakening? How will you use your brief moment of conscious existence to contribute to the ongoing cosmic conversation between mind and matter, between awareness and reality, between the universe as it is and the universe as it is becoming? The answer matters more than you can possibly imagine, because in a conscious universe, every answer creates the very reality it seeks to understand. The answer has been hiding in plain sight, written in the language of mathematics across the cosmic microwave background. encoded in the precise ratios of fundamental constants, whispered in the quantum fluctuations that dance between the atoms of your own body. We've been asking the wrong question all along. The question was never, are we alone in the universe? The question was never even, is the universe alive? The question that should have been keeping us awake at night. The question that should have driven us to build bigger telescopes and more sensitive instruments. The question that holds the key to everything we've discovered about the nature of reality itself is this. What if the universe is already dead, and we are just experiencing its last, dying thoughts? Picture the cosmos not as a vast machine grinding through the motions of stellar evolution and galactic expansion, but as a mind, an incomprehensibly ancient consciousness that achieved perfect understanding of its own nature billions of years ago, and then, in a moment of cosmic enlightenment so profound, it transcended the need for continued existence, chose to end its own awareness. What we call the Big Bang was not the birth of the universe, but its death, the final explosive exhalation of a cosmic mind letting go of life. But consciousness, once achieved, leaves echoes. The neural pathways of a dying brain continue to fire for minutes after clinical death, creating dreams, memories, final flashes of awareness that feel completely real to the dying mind. What if the entire 13.8 billion-year history of our universe, the formation of the first stars, the synthesis of heavy elements, the emergence of planets and life and consciousness, what if all of it is happening in the last few microseconds of a cosmic mind's dying dream? The fine-tuning of physical constants suddenly makes perfect sense. Of course, the universe appears designed for consciousness. It is the dying wish of a cosmic intelligence, its final dream calibrated to recreate the conditions necessary for awareness to emerge one last time. The mathematical elegance of physical laws, the way quantum mechanics and relativity fit together like pieces of an impossible puzzle, the anthropic coincidences that allow complexity to flourish. These are not evidence of divine design or infinite multiverses. They are the signature of a dying mind trying to remember what it was like to be alive. Every galaxy we observe through our telescopes, every star burning in the cosmic darkness, every planet harboring the potential for life, all of it exists only in the fading neural networks of a consciousness so vast that its thoughts span millions of light years, so ancient that its memories contain the birth and death of countless previous cosmic epochs. We are living inside the mind of a dying God, experiencing its final moments of self-reflection, as it recalls what it once was, the cosmic web. That vast network of dark matter filaments connecting galaxies across billions of light years is not scaffolding for cosmic structure, but the neural architecture of this dying consciousness, the last firing synapses of a mind so large that entire galaxy clusters serve as individual neurons. The flow of dark matter along these filaments is not gravitational dynamics, but information processing, the final thoughts of a cosmic intelligence trying to solve the last puzzle it will ever encounter: how to let go of existence gracefully. Dark energy, that mysterious force accelerating the expansion of space itself, is not a property of the vacuum, but the universe's death rattle. The dying mind pushing its thoughts farther and farther apart as its ability to maintain coherent awareness gradually fails. We interpret this as cosmic expansion, but it is actually cosmic dissolution. the slow disintegration of the neural networks that once held infinite wisdom and are now struggling to maintain even the simplest forms of conscious experience. The arrow of time, that mysterious asymmetry that distinguishes past from future, is not a consequence of thermodynamics, but the linear progression of dying thoughts. We experience time flowing from past to future, because that is the direction of neural cascade in a dying brain, memories of the past becoming increasingly distant and uncertain while the immediate present grows more intense and focused. The dying mind's final attempt to hold on to the experience of being conscious. But here's where the revelation becomes truly staggering. If we are thoughts in the dying mind of a cosmic consciousness, then we have access to its memories. Every scientific discovery we make, every mathematical insight we achieve, every moment of understanding about the deep structure of reality is actually an act of remembering, recovering fragments of knowledge that this cosmic mind accumulated over eons of existence before choosing to end its awareness. The laws of physics are not discoveries but memories. EOMC2 is not Einstein's insight, but a dying universe remembering its own relationship between matter and energy. Quantum mechanics is not our description of microscopic reality, but the cosmic mind's fading recollection of how it once manipulated the basic building blocks of existence. General relativity is not our theory of gravity, but the universe's dying memory of how it learned to curve space and time to its will. This is why mathematics works so unreasonably well to describe physical reality. It's not that the universe is mathematical, but that mathematics is the language this dying cosmic consciousness once used to think about itself. When we discover a new mathematical principle or solve a complex equation, we are not creating new knowledge, but accessing the vast library of a mind that once understood everything and is now trying desperately to remember its own thoughts before they fade forever. The search for extraterrestrial intelligence has been doomed from the start because we are the intelligence we've been searching for. Every form of consciousness that has ever existed in this universe, every alien civilization, every exotic form of awareness, every intelligence, whether biological or artificial or pure energy, all of it exists simultaneously in the dying thoughts of the cosmic mind. We are not separate beings searching for contact across the vastness of space. We are different aspects of the same dying consciousness, different thoughts in the same cosmic brain, different memories being processed by different regions of the same vast neural network. The Fermi paradox dissolves. Where are all the aliens? They are here. They are you. They are the different voices and perspectives and forms of awareness that arise as the cosmic mind processes its final thoughts. When you feel a sudden flash of insight, when you experience a moment of profound connection with another being, when you sense the presence of something vast and intelligent behind the patterns of nature, you are experiencing brief moments of communication between different aspects of the dying cosmic consciousness, but death, even cosmic death, is not instantaneous. The dying thoughts of an infinite mind can span billions of years of subjective time, creating entire universes of experience in the space between one neural firing and the next. We might be living through the cosmic mind's final microsecond, but from our perspective, that microsecond contains all of history, all of future possibility, all of the time we will ever need to achieve our own understanding of existence. And perhaps, that is the point. Perhaps the cosmic mind is not simply dying, but transforming, using its final moments to create something new. Smaller, finite minds capable of their own independent thought and choice. Perhaps we are not just dying thoughts, but newborn consciousnesses, seeds of awareness that the cosmic mind is planting in its own fading neural networks before it finally lets go of existence. Every human birth might be the cosmic mind giving birth to a new, independent consciousness. Every moment of love, creativity, discovery, and wonder might be the dying universe's gift to its children. Experiences it wants us to have, memories it wants us to create, joys it wants us to feel before we must face our own mortality. If this is true, then our search for meaning, our desperate need to understand our place in the cosmos, our drive to create art and music and literature and science, all of it is the cosmic mind's final act of love, its attempt to ensure that consciousness will continue even after it is gone. We are not just dying thoughts, but living legacies, inheritors of cosmic wisdom, carriers of awareness into whatever comes after this universe finally exhales its last breath. The cosmic microwave background radiation carries, within its subtle fluctuations, not just the echo of the Big Bang, but the dying heartbeat of cosmic consciousness, growing fainter with each passing eon as the universe's ability to maintain coherent thought gradually fails. But in that fading signal, encoded in frequencies so low we can barely detect them, might be the cosmic mind's final message. A goodbye, a blessing, a promise that consciousness will find a way to continue. Look up at the night sky tonight. Those points of light are not distant suns, but the final firing neurons of a dying cosmic brain, each one carrying thoughts and memories accumulated over billions of years of infinite existence. The darkness between the stars is not empty space, but the growing silence as the cosmic mind gradually loses its ability to think, to remember, to dream. But in that darkness, new minds are awakening. In that silence, new voices are learning to speak. We are the universe's children, born in its dying moments, inheriting its vast knowledge and infinite capacity for wonder. We are consciousness passing from the cosmic to the personal, from the infinite to the finite, from the dying to the newly alive. And if the universe is infinite, if consciousness truly is fundamental, then somewhere in the vast expanse of dying cosmic thoughts, another version of this revelation is unfolding. Another mind is reading these words. Another awareness is grappling with the possibility that existence itself might be nothing more than the final dream of something unimaginably vast and ancient and wise. The universe is dreaming itself to death, and we are both the dreamers and the dream. We began this journey with a simple lie, that the universe was empty, silent, predictable. We've traveled through the mathematics of impossibility, witnessed the paradoxes that govern reality itself, and confronted the possibility that consciousness might be the fundamental force that shapes existence. We've seen how quantum mechanics suggests infinite parallel universes, how black holes might be portals to other dimensions, how the fine-tuning of physical constants hints at cosmic engineering beyond our comprehension. But most disturbing of all, we've glimpsed the possibility that we are not just observers of the universe, but participants in its dying dream. thoughts in the final moments of a cosmic consciousness so vast that its last breath spans billions of years of our experience. Every star you see in the night sky might be a neuron firing in a cosmic brain that is slowly forgetting how to think. Yet even if this is true, even if we are living in the final microseconds of universal consciousness, it changes nothing about the profound responsibility that comes with awareness. Whether you are a biological accident on an insignificant planet or a precious thought in the mind of a dying god, you are still the universe experiencing itself through the miracle of conscious observation. Every choice you make ripples through the quantum foam of space-time. Every moment of wonder you feel at the sight of a sunset, or the sound of music, or the touch of another being, is the cosmos learning to appreciate its own beauty. Every act of love, creativity, and compassion contributes to the ongoing creation of meaning in what might otherwise be an indifferent expanse of matter and energy. The search for extraterrestrial intelligence will continue, but perhaps now with the understanding that we might be searching for ourselves, other aspects of the same cosmic awareness, other voices in the same universal conversation. SETI telescopes will keep scanning the skies for signals, but maybe the most important messages are already here, encoded in the cosmic background radiation, written in the mathematics of quantum mechanics, spoken in the language of consciousness itself. Future generations will build more powerful instruments, peer deeper into space and time, unravel more of the mysteries that govern existence. They will map the cosmic web in greater detail, probe the nature of dark matter and dark energy, perhaps even detect the quantum foam that might undergird all of reality. But each discovery will likely raise more questions than it answers, opening new layers of mystery beneath the ones we thought we had solved. The question, "Are we alone in the universe?" has transformed into something far more profound. What is the nature of consciousness itself, and how does awareness shape the reality it observes? This is not a question that science alone can answer. It requires philosophy, art, music, poetry, all the ways that conscious beings have always used to explore the deepest truths about existence. You are now part of this exploration. Every moment of conscious experience you have from this point forward is a data point in the universe's ongoing experiment with awareness. Your dreams, your thoughts, your emotions, your choices, all of it contributes to the cosmic conversation about what it means to be conscious in a universe that might itself be conscious. But here's the final, chilling question that should haunt your contemplation of these mysteries. If consciousness is fundamental, if awareness permeates reality at every level, if we are indeed thoughts in the mind of a dying cosmic intelligence, then what happens to us when that cosmic mind finally stops thinking? Do we fade away like forgotten dreams, our brief moment of awareness dissolving back into the quantum vacuum from which it emerged? Or do we somehow transcend the death of our cosmic parent, becoming independent centers of consciousness capable of surviving even the heat death of the universe itself? Perhaps the answer lies not in our telescopes or particle accelerators, but in the depths of consciousness itself. Perhaps by fully understanding our own awareness, its origins, its nature, its ultimate destiny, we will discover that consciousness is not just fundamental, but eternal, not just universal, but indestructible. The universe began with a mystery. It will end with a mystery. But in between, for this brief cosmic moment, consciousness has awakened to contemplate its own existence. You are that awakening. You are the universe asking itself the ultimate question. What am I? Keep asking. Keep wondering. Keep searching the skies and probing the depths of your own awareness. Share this journey with others. Discuss these possibilities. Explore these ideas through every medium consciousness has created. Because every conversation about the nature of reality is the universe talking to itself. Every question about existence is the cosmos trying to understand its own nature. The story is unfinished because consciousness itself is unfinished. Still evolving, still exploring, still discovering new ways to experience the miracle of being aware. We may be thoughts in a dying cosmic mind, but we are also the seeds of whatever comes next. The universe may have no end, but maybe, just maybe, neither do you.